It was the summer of 2007 that we first started to engineer the PerfectWave series. 2 years later, in the summer of 2009, we introduced two new products, the PerfectWave Transport and the PerfectWave DAC. These two products changed the landscape of digital audio in their time. 2 years later, in 2011, the PerfectWave line expanded to include the power plants. The P5 and the P10 were both introduced in January of 2011.
The engineering challenge for the PerfectWave line was bringing together the best mix of components and assembly techniques to allow us to achieve world-class quality in the components while keeping the cost affordable. It's very easy to spend 2, 3, and 4 times what the PerfectWave line achieves and not to beat it in terms of performance.
Yeah, I think we wanted to go away from the utilitarian look that a lot of hi-fi has. And what we were looking for was something a little more elegant and sleek and with a really good wife acceptance factor. There were lots of challenges with the PerfectWave products. We were doing things that we'd never done before. We'd never used castings before. We had never married extrusions and sheet metal in the way we were doing it. We'd never had a highly polished top cover. These were all new things to us. In addition, we decided to throw in a touchscreen. Only you couldn't use something the size of an iPod. You had to have something that people could read from a little bit of a distance. We had to have something that they, enough room for them to start punching in things on the touch screen. And of course, we started out with an idea of a 2-inch tall product, but then here comes the touch screen, and it forced us into closer to 4 inches, which is what we have today.
Engineering the PerfectWave products was both very exciting and very challenging. Coming up with a flagship line of products has the potential of so many things, and there are so many choices to be made, and you want to choose the best part for everything. There are so many choices in every little detail, down from the DAC chip to the resistors. Every part was chosen to be the best part for that application. There's a tremendous amount of time involved in making all those decisions.
The boards that we build for PS Audio are run on our high-speed, high-end surface mount line. So there's a couple of technologies that we use. They use some mixed technologies in their boards. They have some surface mount components, which are basically laid on top of a flat surface. We silk screen a solder paste onto those boards, and then we pick in place with very precision equipment, very high-end equipment, components down to 10 thousandths by 20 thousandths, sometimes the size of a speck of pepper, basically. So you have to use high-end equipment to do that, laser-guided equipment, very long reflow ovens here. We have automated optical inspection equipment that we use once we've placed these parts. Basically, once you put that paste down, run them through these ovens, it glues the parts to the board. So we inspect for those solder joints. PS Audio has a very high quality standard. They use high-end parts. We use automated optical inspection to look at them with. We have X-ray equipment that we can get down inside to look at the solder joint quality. So
one of the most important design choices was in the resistor components used in the analog circuitries in the PerfectWave DAC. And there are many resistors out there that are less than a penny a piece, and they work okay in most situations. We had to find resistors that were better, and some are as much as 100 times as much as your average resistor, but they do sound better, and that's what we chose for the PerfectWave DAC.
this is very high-tech work. Most people think that the high-tech work that occurs on these kinds of these types of technologies all happens overseas. Actually, it all started here first. A lot of it's moved offshore, but a lot of it still occurs in the United States. We were the leaders in the industry initially. So yes, we build very high, complex technologies for lots of folks in the area.
We take every piece, every chassis, everything that goes into the unit. We take a look at 100% inspection and make sure that it's perfect. You know, make sure that that customer is getting what they want and what they actually paid for. And yeah, we take pride in every single piece of metal that goes into each chassis.
Built in Boulder means to the engineering group intimate daily involvement with the issues that are associated with building a top-of-the-line audio product. We get involved with production issues, assembly issues, testing issues, quality issues, vendor issues. So every week, engineering is involved with keeping the PerfectWave line the flagship product for PS Audio.
There were a lot of challenges in getting the graphic touchscreen integrated into our products. Having a graphic display is much more complicated than a simple text display. It requires a lot more memory to store all the graphics. It requires a lot more processing power to keep the display updated. So we had to have a faster processor, 32-bit, instead of a normal 8 or 16-bit processor that would be in a product such as this. We had to have a large amount of flash memory to hold all the graphic images, display controllers, and associated other chips. Plus, we needed to be able to update all these pieces of software in the field, which presented another set of problems as well.
Talk about cutting edge. When we first launched the PerfectWave Transport to the world in January of 2009, we had a big press conference at our room in CES. And the press was waiting. Keith Johnson, the recording engineer for Reference Recording, was in the audience. And we were going to demonstrate on one of Keith's recordings the first time that a single component piece could play a 192 24-bit WAV file, just slip the disc in and play it. And we were excited, but there was only one little problem. It didn't quite work. We had most of it going. We had 4 people from the engineering department in the bathroom of the Venetian Hotel finishing the code, and within a minute or two of the press conference, I was able to say, "Does it work?" And they said yes. We took it out, hooked it up, pulled the curtains back, played it, and Keith Johnson turned to me and said, "Paul, that sounds exactly like the master recording." That was pretty wild.
For us to make the PerfectWave look like it looks and be a good neighbor as far as EMI is concerned, shielding it as best we can, kind of necessitated that we build a box within a box. So we put basically all our electronic components into a shielded box and made sure it was absolutely not emitting, and we did this by taking it up to testing labs, and cost a lot of money and took a lot of time.
EMI, or electromagnetic interference, is radio frequency energy that's generated by electronic circuits. There are rules and regulations about EMI and making sure that your product does not emit that into the environment. But also for audiophile equipment, it's very important that any EMI in the environment on the outside be kept out, not interfere with the workings of the device.
We put together the top plate and we put fingers along the top plate, so what it does is it grounds the top of the chassis and keeps the radiation inside of the unit, so the whole unit is just circumferentially grounded and perfect, keeping that radiation out.
As I said, we wanted to move away from the industrial look of audio equipment, and we wanted a more elegant design. And one of the things that we did was juxtaposed the very beautiful piano finished top cover that's been just polished and polished until it glows. And then we have a solid, very substantial aluminum frame that this sits in. And you have the juxtaposition in between the beautiful polished top, the industrial looking kind of sides, and then you have these beautiful shapes though that are in this industrial piece. You know, you have these corners that aren't true corners, they're more compound, so they sweep instead of just be around function like maybe on an Apple product. Yes, it's a beautiful piece of gear, and it's something that I'm proud of.
It takes a little bit more time, a little bit more delicacy, a little bit higher quality of a process. So when their parts come in, we get them disassembled. We have a couple guys that come in, assemble all the units. From there, the parts get washed to get rid of dust, dirt, oil, metal shavings, and also to kind of pre-treat the metal. Once they are pre-treated, you pre-bake them to get out any other residual oils, water, all that stuff. From there, they get masked up because PS Audio requires certain parts of their units to be free of powder. All the powders that were out there didn't have a high enough wax content so that when you went to actually touch them, they left your fingerprints on there. So we went to one of our manufacturers and told them this is what we want. And they came up with a special formula for PS Audio, and that's what we use. But because of that, it's a little bit trickier to shoot as well. You have to work a lot harder to get it in all the corners and crannies and everything like that. But what PS Audio wants, PS Audio gets.
It takes a lot to build a product line like the PerfectWave series, from state-of-the-art measurement equipment to a great engineering team, and in particular, a great listening room. Because at the end of the day, you can't listen to the meters. You have to listen to the products, which we do every step of the way. It's the only way that we're able to produce products that actually get to the soul, the source of the music, what the composer and the artist are trying to say. That's what it's all about for us. We sure appreciate you watching our video. See you later.